Hi everyone, I'm Santhi from Department of Mathematics and Statistics, Bhavan Vivekananda College. I'm here with my lesson 17 in linear algebra on vector spaces. In this lesson, I'm going to explain about null space of a matrix A of order m by n. Before I define null space of a matrix, let me give some explanation about this homogeneous system of equations which are reduced to matrix equation and then leading to null space concept. So consider a homogeneous system of equations. So here I have taken three equations for example with four variables. So these three equations, then to solve these equations, we'll write their corresponding matrix equation. How do we write them? By taking these coefficients, it can be written as a matrix here which is obtained by taking the coefficients of x1, x2, x3, x4 in the above equations. So we'll get here a 3 rows, 4 columns, 3 by 4 matrix into how many variables we have x1 x2 x3 x4. So a column matrix with 4 rows x1 x2 x3 x4 is equal to the right hand side a column matrix with 3 rows that gives the right hand side of these equations 0 0 0. So if you multiply this, you will get back again to this system of equations. This we learned earlier to solve system of equations. Then if you observe this matrix, it is a rectangular matrix which has 3 rows and 4 columns, so 3 by 4 order. And this column matrix x1, x2, x3, x4 of unknowns, take it as x, then we'll obtain here a matrix equation Ax is equal to 0. Then this system, what do we mean by solution for this system of equations? Getting the values of x1, x2, x3, x4. That means finding out this column vector x1, x2, x3, x4. That means finding out a vector x which satisfies this equation. Then this system may have either a unique or infinite solution as we learned earlier. Unique solution means zero solution which always exists for homogeneous system. Infinite solution means non-zero solutions. So then a set of all the solutions, we call it as the null space of the matrix A. That means the set of all the vectors x which satisfy the equation Ax is equal to 0. That is nothing but the set of all the values of the points x1, x2, x3, x4 will give you null space of the matrix A. Now let us define null space of a matrix. Definition of null space. The null space of a matrix A m by n is a set of all solutions of the system of homogeneous equations given by the matrix equation Ax is equal to 0. That means if you take a matrix A with order m by n, that means n rows and n columns, which is obtained by the homogeneous system of equations and which can be solved by the matrix equation Ax is equal to 0. Then the solutions of this matrix equation give us null space. So it is given by null A. We will denote it with null A is equal to set containing all the vectors u belong to Rn. What do we mean by Rn? This u is a column vector n rows. Why it is n rows? Because it is a matrix of order m by n. So it will have n columns. That means there will be n variables which are there for the homogeneous equations. So null A is equal to set containing vector u belong to Rn such that Au is equal to 0. If you multiply matrix A with vector column vector u, it should give you 0. Now suppose any vector u is given and we have to decide whether that vector u is in null A or not. We have to follow two conditions. So a given vector u belongs to null space of a matrix A m by n if it satisfies the following two conditions. Number 1, u belongs to Rn. That means that is number of rows in u is equal to n. Second one, Au is equal to 0. That is the vector u satisfies the equation Ax is equal to 0. So this is null A, set of all the solutions of Ax is equal to 0, which we call it as null space. And if any vector u is given, how do we check whether that vector belongs to null space or not? We have to follow these two conditions. Now let us look at this example. You are given a matrix A is equal to It has 2 rows and 3 columns. So what is its order is 2 by 3, and you are given 3 vectors x1, x2, x3. So now let us check whether x1, x2, x3 belong to null A or not. So this is what we want to check it. So what is the matrix given to us? A is the matrix 1 minus 3 minus 2 minus 5 9 1. What is its order? Its order is, it has 2 rows and 3 columns. So here that means that is what we have here. M by n is equal to 2 by 3. Therefore, what is n value is 3. So we want Rn is equal to R3. This is what the information we have here. Now let me consider the first vector. Consider x1 is equal to 5, 3 minus 2. Then we have to check two conditions. For x1 belong to null A, it must satisfy two conditions. What are those two conditions? First one is this x1 must belong to Rn. What is Rn here? That is R3, because n is equal to 3. And the second one, A into x1 must be equal to 0. So now let us see how are these two conditions satisfied. So first condition, that let us take the first one. First condition. So x1, what is the order of x1? Order of x1 is, it is of it has 3 rows. What is x1 here? 5, 3, 5 minus 3, 2. So its order is 3 by 1. x1 order is 3 by 1. Therefore, x1 belong to, what are the, we'll write therefore. Here you have n is equal to 3, which is equal to a number of rows in x1. Therefore, x1 belong to R3. The first condition is satisfied. Now let us see look at the second condition. Second condition that we have, Ax1 is equal to, that is A into 1 minus 3 minus 2 minus 5 9 1 into x1 is 5 3 minus 2. Let us multiply. So 5, first row first column, minus 9 plus 4, and then minus 25 plus 27 minus 2, which is equal to 0 0. Therefore we have Ax1 is equal to 0. Then what can we say by this? By 1 and 2 we have x1 belong to null A. This is what we have to check. Now let us look for the second one. Second vector. This is first vector. And now let us look for the second vector. In second I have, that is, I have vector, consider x2 is equal to. So what is x2 here? 1 minus 1. What is its order? Its order is 2 by 1. But I have here n is equal to 3. It is not equal to 2. That is, number of rows in X2. What do you mean by that? Which implies X2 does not belong to R3. Hence, X2 does not belong to null A. So first condition itself is not satisfied. Therefore, we say that it is not in null A. Now let us look at X3. What do we have for X3? X3 is equal to, this is the third one. X3 is equal to 1, 1, 1. What is its order? It is 3 rows and 1 column. So I have here, therefore, n is equal to 3 is equal to 3, that is number of rows in X3. Therefore, X3 belong to R3. First condition is satisfied. Now let us look at the second condition in this. What is the second condition? Ax3 is equal to, that is minus 1, not minus 1, it is plus 1. 1 minus 5 minus 3 9 minus 2 1 into x3 is 1 1 1, so which is equal to 1 minus 3 minus 2 and then minus 5 plus 9 plus 1, so which is equal to minus 4 and then this is 5. This is not equal to 0 0. That is Ax3 is not equal to 0. Hence x3 does not belong to null A. So for any vector to be null A, it has to satisfy two main conditions. That is, the first one is it should have the same number of rows as number of columns in A. The second one is it should satisfy the equation Ax is equal to 0. So here the three vectors given. The first one we had, first one is in null A, second one is not in null A because it does not, it is here number of rows is equal to 2 and n is equal to 3 here. Therefore, it cannot be in that x2 does not belong to R3. So, and then for the x3, it belongs to R3, but Ax3 is not equal to 0. Therefore, it cannot be in the null space. Till now we checked when a vector is given, how will that vector be in null space. Now we have another concept, spanning set for null A. What does it mean? All the vectors in null A can be described by its spanning set, which is called as spanning set of null space of A. That means we were checking a vector is given, whether it belongs to null A or not. But how many vectors will be there in null A? What all the vectors? Not like how many, but what all the vectors which are there in null A can be described by its spanning set. How? That is, if null A is equal to, suppose, a span of set containing v1, v2, v3 and so on vn, then the set containing v1, v2, v3 and so on vn is called as its spanning set. And here we have to note down some points. If null A is equal to span of set containing 0, what does it mean? Null A is equal to only set containing 0. Why? Because span of set containing 0, that means all linear combinations of 0. Any linear combination with 0, that is nothing but a scalar multiples of 0, all will be zeros. So, when you have null A is equal to span of set containing 0, then null A will have only 0 element, and that is null A is a finite set with only 0. Then the second point, if null A is equal to span of a finite number of elements v1, v2, v3 and so on vn, then null A is an infinite set containing all the possible linear combinations of v1, v2, v3 and so on vn. So here this is spanning set v1, v2, v3 and so on vn, which has finite number of vectors. But span of this finite set will have infinitely many vectors. Then null A also will have infinitely many vectors. So we have the only two possibilities. Either null A has only 0 element, then which is finite, or null A will have infinitely many elements which are linear combinations of V1, V2, V3 and so on, Vn, that is elements from the spanning set. Hence we can note here that the spanning set of null A is finite, whereas null A can be infinite also. Now let us see what do we mean by finding or describing null A. We have noted 2 points in the previous explanation. If null A is equal to span of set containing 0, then null A will have only one element, a singleton set 0. Otherwise, if null A is not equal to set containing 0, that means it is not only having 0 element, then null A contains infinitely many vectors which are spanned by a finite set of vectors. These points we discussed before also. Hence, finding or describing null A is nothing but finding vectors that span null A. That is finding spanning set for null A. Here null A means it is a null space. It is a vector space in fact. So we cannot list out all infinite elements of null A. So what can we do is we can only describe null A. So describing null A is nothing but giving a spanning set for null A. Now let us see the method to find or describe null A. So here are the points. The first point, let A be a matrix of order n by n. So you are given with a matrix A directly, which has order n by n, for which you have to find or describe null space of matrix A. Then the second point, consider the augmented matrix AO. That means with this A, add 0 column and then make augmented matrix where O is a column of zeros. Then point number 3, reduce this augmented matrix to echelon form. This already we have been doing it. And identify, what are the things you have to identify? Pivot columns, basic variables and free variables. So you have to identify all these three: pivot columns, basic variables and free variables. Then after that, express basic variables in terms of free variables. So because suppose you have 4 variables, among 4 you may have some basic variables, some free variables. Then the basic variables, express them in terms of free variables. Then point number 5, null A is equal to set containing vector x such that where the vector x is a column vector that has basic variables given in terms of free variables. So you can describe null A as set of vector x. Then what will that vector x have? It will have the variables, basic variables which are expressed in terms of free variables. That will give us a span of set containing V1, V2, V3 and so on Vn. This is obtained by expressing basic variables in terms of free variables. So when finding this null A or describing null A or finding spanning set of null A, all are the same. We can note down these points which are have been repeated many times. The first one is, if all the columns are pivot columns in the echelon form of this augmented matrix A, then no free variable and hence null A will have only 0 element. Then point number 2, number of vectors that span null A, that is number of vectors in the spanning set, is equal to number of free variables. Because here when you don't have free variables, then there won't be any basic variables to express in terms of free variables. So you will have in null A only one vector, 0 vector. But then how many vectors will be in the spanning set of null A? That will be equal to number of free variables. This we can note it down immediately by looking at an echelon form of the matrix. We can immediately mention how many vectors can span the null space. Let us work out one problem in finding or describing null A. So here matrix A is given with the 3 rows and 1, 2, 3, 4, 5 columns. So this is 3 by 1 to 3 by 5 matrix. Even this you can even call this problem as, or um, you can call describing a null space or finding spanning set also. Finding spanning set. So any set of null A. Matrix A is given. Either you are asked find null A or describe null A or find a spanning set for null A. We'll do the same. Then what were the points I gave it in method finding this? The first point is consider a matrix A which is given to you and of order 3 by 5. Then what you have to write? You have to write the augmented matrix. So consider augmented matrix. So with what you will augment this matrix? With a column with zeros. So you will have here that is the entire zeros I have. So it is -3, 6, -1, 1, -7, and then 1, -2, 2, 3, -1, and then 2, -4, 5, 8, -4. Then this should be augmented with column zeros. Why? Because like you will get here linear equations which are homogeneous. All that we are not discussing, we are giving the procedure. Now we have to reduce this to echelon form. So reduce it to echelon form. Reduce into echelon form. So if I observe here, we have the first row, first column element is -3. Instead this I think we can make it more simple. Let us interchange this row 2 with row 1. So I'll do that first step. I will do that for R2. Not R2, R2, R1 is interchanged with R2. Then I'll get the matrix as -3, 6, sorry. So first we'll interchange the rows R2 and R1. So what is the our transformation that we are applying? Interchange R1 with R2. So this matrix will become R2 second row 1 -2 2 3 -1 with 0, and this is going to -3 6 -1 1 -7 0, and the third row as it is 2 -5 8 -4. Then let us mark the pivot position. This is the pivot position. Now using this I have to make these two zeros. So the operation what we'll apply here is for R2 R2 plus 3 times R1. Fine. So let us see what happens. 1 -2 2 3 -1 0, and -3 plus 3, so R2 plus 3 R1 will be 0, and 6, then plus 3 into -2, this is also 0, and then -1 plus 3 times 2, that is 6 -1, which is 5, and then 1 plus 3 times 3, which will give us 10, and then the last one anyway it will be, and one more -7, right? -7 plus 3 times -1, which will give me -10, and this is anyway 0 because these are both are zeros. Now we have the third row. For third row, what is that operation we'll apply? For R3, so 2 -2 will be 0, so we'll have R3 -2 R1. So if we do this, what do we get here? The elements, this will be anyway 2 -2 0, and then -4, then -2 into -2, which is also 0, and the next one is 5 -2 times 2, 5 -4 is 1, and the next one is 8 -2 times 3, 8 -6 is 2, and the last one is -4, and then minus 2 times minus 1 minus 4 plus 2 is minus 2, and this one will be anyway 0, and here also we have 0. So this is what we got now. So now let us mark again the pivot positions. This is pivot, and then already we made these two zeros, and in the second row it is the pivot position. This is the pivot position. And I think before making the third row, this 1 0, let us simplify this R2. So what is our next task is, let me clear this. So my next task will be simplifying R2. So for R2, I'll do R2 divided by 5. Then this matrix will be reduced to 1 minus 2, 2, 3 minus 1, 0, and then 0, 0, 1, 2 minus 2, 0, and last two remain same now, 0, 0, 1, 2 minus 2, 0. If you observe here, let us mark pivot position and pivot position, and if you observe, these two rows are nothing but the same. So how can I make using this zeros? So my next operation will be for R3 minus R2. So the matrix will become here 1 minus 2, 2, 3 minus 1, 0, 0, 0, 1, 2 minus 2, 0, and 0, 0, 0, 0, 0, 0. So let us look at the pivot positions. This is pivot and this is pivot. By now I think we got it in echelon form. Now what is the next task? We have to find out null A. So from this echelon form, we need to find null A. Then to find null A, we have to mark first what are the pivot columns. So we have to find what are pivot columns, what are basic variables, what are free variables. All these we have to find out now. Now let us look at for that. So from echelon form, I will be now marking here which are the C1 is a pivot column, and the C2 is not a pivot column, and C3 is a pivot column. So what are pivot columns here? So for us, pivot columns are C1 comma C3. That implies we have here what are the basic variables. Then if I think the variables are how many columns are there, those many variables. This is x1, x2, x3, x4 and x5. Okay, so now you have the variables, that is which are the variables among these. C1, C3 are pivot columns implies x1 comma x3 are basic variables. So now you have here 5 variables. What are those 5 variables? You have here x1, x2, x3, x4, x5. Among these 5, x1 and x3 are basic variables. Then what are the free variables? Implies x2, x4, x5 are free variables. These are important for us. These free variables are important for us. And now what is our next task is, write the equations from echelon form What do we get the equations? We'll get the equation. These are the rows, like you have x1 minus 2x2 plus 2x3 plus 3x4 minus x5 is equal to 0, and the next one is you have here x3 plus 2x2 minus 2x4 is equal to 0. Let us write the equations. X1 minus 2x2 plus 2x3 plus 3x4 minus x5 is equal to 0. Another equation is x3 plus 2x5 is equal to 0. So from these two equations, what do we have to do? Let me give the numbers. This is equation 1 and 2. Then what do we have to do? From 1 and 2, express basic variables. What are the basic variables? x1 comma x3 in terms of free variables, that is x2, x4, x5. So I'll write here, then 2 implies, in 2 I have x3, x4, x5. Among these, which is the basic variable? x3 is the basic variable. So I will write here x3 is equal to minus 2x4 minus 2x5. So this I will give equation number 3. Now one basic variable x3 is expressed in this. What is another basic variable? This is over. What is another basic variable? x1 value we want. So we will use here from 1. Equation 1 implies. So in 1 I have x1 is a basic variable. Keep basic variable one side, send all the other variables another side. I will get 2x2 minus 2x3 minus 3x4 plus x5. In this I have x3 value already in 3. Substitute x3 value. So you will get 2x2 minus 2 into x3 is minus 2x4 minus 2x5 minus 3x4 plus x5. So what did I do here? Substitute 3. That is what you have done here. So this will give you, simplify this, and you will get 2x2, and where is another x2? Is there any other x2? Only 2x2. And I have plus 4x4. So this is plus 4x4 plus 4x5 minus 3x4 plus x5. So this will be equal to 2x2 plus 4x4 minus 3x4 is x4, and then plus 4x5 and plus x5 will be, and this should be, I think this is plus, so that I will have here this as plus, and then here I will be having this as minus. So minus 4x5 plus x5 will be minus 3x5. So now what do I have here, which implies I have x1 value as 2x2 plus x4 minus 3x5. This is 4. This equation is 4 for me. So from 3 and 4, in 3 we expressed x3 in terms of x4 and x5, and in 4 we expressed x1, the basic variable, in terms of x2, x4 and x5. So now I have to write describing null A. Then what will be my null space? Then null A is equal to, it has the vector x, that is equal to how many? x1, x2, x3, x4, x5. Why? Because this is belong to R5. Why? Because what is a matrix A? Matrix A is 3 by 5 matrix. Then null A will be a subspace of R5. Null A will be a subspace of R5. Therefore, this vector in null space vector will have 5 rows. So This will give me. But what are these such that this is given such that I have here this these two conditions I have. What is that? What value I got? X1 value as 2x2 plus x4 minus 3x5, and x3 value as minus 2x4 plus 2x5. This is what for this I will write it in more simpler way. Null A is equal to x is equal to, let me have this to x1, x2, x3, x4, x5, that is equal to, what is x1? 2x2 plus x4 minus 3x5. What is x2? X2 is a free variable, then don't change it. What is x3? X3 have the value minus 2x4 plus 2x5. Then what is x4? It is a free variable, don't change it. What is x5? Free variable, don't change it. So this is nothing but, you can write this one as I can, because here how many parameters I have? X2, x4, x5. So I will take x2 common. If I take x2 common, I can write it as here 2, and in the second row 1. There is no x2 in the third, so it is 0. There is no x2 in the fourth row, 0. Fifth row also x2 is not there. Plus, what is the next free variable? x4. x4 1, this is 0 and minus 2, and then this is 1 and then 0, plus x5. Then you have x5, the coefficient is minus 3. There is no x5 in the second row, and the third row there is x5 which is 2, and in the fourth row there is no x5, and fifth row there is x5. So how many vectors are spanning? That is nothing but, therefore I can say null A is span of how many vectors? 2 1 0 0 0, 1 0, minus 2 1 0, minus 3 0 2 0 1. So if I take this as V1, V2, V3, then I will have, hence null A is span of V1, V2, V3. It doesn't mean that null A has only 3 vectors. It means that null A has all linear combinations of V1, V2, V3. That is what you can see here. You can make linear combinations of these 3 vectors. You can choose x2 as any value because it is a free variable. x4 as any value, x5 as any value. Choose these as any values, and then you can form all the linear combinations. This is what we mean by describing null A, or finding null A, or finding a spanning set for null A. Everything, it is the same. Till now we found how to get a null space for a given matrix. Now, as the name says null space will be also a vector space, and in later course we will prove that this null space is a subspace of some vector space. That we'll discuss when that point comes. Now what I want to mention here is null space will be also a vector space. Then if it is also a vector space, then it will be also a finite dimensional vector space when the given vector space is a finite dimensional vector space. Then it will have a basis and it will have dimension. So now we will see how to find the basis and the dimension of null space of a matrix A. That is for null A, we call it as. So here we have, as we observed in the previous problems and definition, null A is equal to span of some given vectors n. Then basis of null A will be equal to the set of these vectors. Then dimension null A is nothing but number of vectors in its basis. Now, previous to this, we found a basis for the null space, and now here, after finding the basis for the null space, we can find the dimension, because dimension is nothing but number of vectors in any of the bases of vector space. Here also, for dimension of null A is nothing but number of vectors in its basis, that is equal to n here. So here we can note down some point that the number of vectors that span null A is equal to, as we observed in echelon form, it will be equal to number of free variables in echelon form of augmented matrix AO. Hence, we can say in short that dimension of null A is equal to number of free variables in the echelon form of the augmented matrix. Now, this let us understand it more by observing the previous example concepts. So we have done previously this same problem for this matrix. So I'll just mention here for the matrix A is equal to a 3 by 5 matrix which you solved in the previous problem. So, and we have reduced it to echelon form, and its augmented matrix, its echelon form is this. So which columns are pivot columns here? C1 and C3 are pivot columns. So if C1 and C3 are pivot columns, then how many C1 and C3 are pivot columns? Means basic variables are x1 and x3. Only two are basic variables. Then the remaining three columns are not pivot columns. C2, C4, C5. That means the remaining three variables are free variables. So here if I say number of free variables will be equal to 3, that is equal to number of columns that are not pivot columns. Or you can say here pivot columns are C1, C3, that implies x1, x3 are basic variables, which implies x2, x4, x5 are free variables. How many free variables are there? 3 free variables are there. Then number of free variables 3, then dimension null A will be equal to number of free variables, that is equal to 3. So to find the dimension of null space, so it is nothing but you have to find basis for the null space. After finding the basis for the null space, how many number of vectors are there in the basis, that will be the dimension of the null space. It is nothing but equal to number of free variables in the echelon form of the augmented matrix.